Good morning, everyone. I'm excited to welcome you to today's presentation. Today, we'll be exploring the fascinating topic of differentiating the causes of landslides in the Himalayan region and Western Ghats. We'll look at what triggers landslides in these two distinct geological regions and understand their unique characteristics. Over the next few minutes, we'll cover the key factors behind landslides in both areas, helping us gain a clearer picture of these natural phenomena. Let's get started. Landslides are essentially mass movements of rock, soil, or debris that slide down slopes, primarily due to the force of gravity. They're quite common in regions that are hilly or mountainous, especially when there's a lot of rainfall or seismic activity, which can destabilize the slopes. For example, both the Himalayan region and the Western Ghats frequently experience landslides. However, the reasons behind these landslides can differ significantly because of variations in geology, climate, and human activities in these areas. Understanding these differences helps us better prepare for and mitigate the impact of landslides in these vulnerable regions. When we talk about the causes of landslides, there are several key factors to consider, and they all play a role in how and when a landslide might occur. First, we have geological factors, which include the type of rocks and soil in an area, as well as the overall stability of the slope. These natural characteristics can make some slopes more prone to failure than others. Next, climatic factors are also crucial. Intense rainfall, seasonal weather patterns, and extreme weather events can all trigger landslides by saturating the soil and reducing its cohesion. Topography, or the shape and steepness of the land, significantly influences landslide risk. Steeper slopes are inherently more vulnerable because gravity acts more strongly on the materials there. Finally, we can't ignore human activities. Deforestation, construction projects, mining, and road cutting can all destabilize slopes, often making landslides more likely or more severe. Understanding these factors helps us see that landslides are often the result of a combination of natural and human influences, which is why comprehensive risk assessment is so important in landslide-prone areas. Let's start by looking at the geological factors that contribute to landslides in the Himalayan region. The mountains here are quite young and are formed primarily through tectonic activity, which means the rocks are often highly fractured and relatively weak. This inherent fragility makes the slopes more susceptible to failure. Additionally, the region is dominated by sedimentary and metamorphic rocks. These types of rocks are more prone to weathering over time, which further weakens the slope stability. When the rocks break down, it increases the likelihood of landslides, especially during periods of heavy rainfall. Speaking of rainfall, climatic factors play a crucial role as well. The Himalayas experience very high monsoon rainfall, typically around 1,500 to 3,000 millimeters annually. This intense and sustained rain saturates the soils, reducing their cohesion and making them more prone to slipping. Most landslides tend to happen during the July to September monsoon months, when the rains are heaviest. The combination of saturated soils and weakened rocks creates the perfect conditions for slope failures, which can have serious consequences for communities and infrastructure in the region. Let's take a closer look at the topographical factors that influence landslide risks. Steep slopes and narrow valleys are particularly vulnerable because their terrain makes it easier for landslides to occur. When the land is so steep, even a small disturbance can cause a slide. Narrow valleys can funnel movement and make the situation worse. Additionally, rivers constantly incise and erode these valleys, which destabilizes the slopes over time. This ongoing erosion weakens the ground, increasing the chances of a landslide, especially during heavy rainfall or seismic activity. Moving on to seismic factors, this region is quite seismically active, falling within zones IV and V, which are considered high to very high seismic zones. Earthquakes here are frequent and often strong enough to trigger massive landslides. The shaking from an earthquake can loosen the soil and rock on the slopes, making them prone to sliding. So, when we think about landslide risk in this area, we need to consider both the natural topography and the seismic activity that can dramatically increase the likelihood of large, destructive landslides. Now, let's look at some human-induced factors that significantly contribute to slope instability. Things like deforestation, unplanned road construction, terracing, and urbanization all play a role in weakening the stability of slopes. When we cut into the land for development or agriculture without proper planning, it can disturb the natural balance and make slopes more prone to failure. For example, in 2013, the Uttarakhand floods and landslides were not just caused by heavy rainfall, but also by this combination of natural and human activities that destabilize the slopes. Similarly, in Sikkim, we saw landslides in 2011 and again in 2023, which were triggered by seismic activity, but also exacerbated by road cutting and other development activities. These examples highlight how human activities, especially when not carefully managed, can significantly increase the risk of landslides. It's a reminder that development needs to be balanced with environmental stability to prevent such disasters. Let's take a closer look at the causes of landslides in the Western Ghats. First, we have geological factors. The region is part of an ancient peninsular plateau, and the rocks here, such as basalts and granites, are generally quite stable. However, the soils formed from lateritic processes are more prone to erosion, which can weaken the slope stability. Although the slopes in the Western Ghats are less steep than those in the Himalayas, the weathered soil layers are still vulnerable, especially during heavy rains, which can trigger landslides. Moving on to climatic factors, the Western Ghats receive a significant amount of rainfall annually, between 2,000 to 5,000 millimeters, primarily due to the southwest monsoon. This heavy rainfall saturates the soil, reducing its cohesion and increasing the likelihood of shallow landslides. Understanding these factors helps us see how both the region's geology and climate work together to make landslides a recurring challenge in the Western Ghats. Let's take a closer look at the topographical factors that influence slope stability. In regions like Maharashtra, Karnataka, and the Kerala Ghats, we see moderate to steep slopes, which naturally make these areas more vulnerable to landslides and erosion. These steep gradients increase the gravitational pull on the soil and rocks, making slopes more prone to failure. Additionally, valleys and cut slopes along roads are particularly susceptible to shallow slips and mudflows. These areas often experience water runoff and disturbances from construction activities, which can weaken the soil structure and trigger landslides. Moving on to human-induced factors, activities like deforestation for plantations, such as tea, coffee, and rubber, play a significant role. When trees are removed, the roots that hold the soil together are lost, making slopes more unstable. Road construction, hill cutting, and mining also contribute to destabilizing these slopes. These activities often involve removing large amounts of earth, creating unnatural slopes and increasing the risk of landslides. Finally, overgrazing and urban expansion further exacerbate erosion. When vegetation cover is reduced due to overgrazing, or when cities expand into hilly areas, the natural protective layer is compromised, leaving the soil exposed and more vulnerable to erosion and failure. Overall, both natural topography and human activities are key factors that we need to consider when addressing slope stability and disaster risk management. Let's look at some real-world examples to understand how these processes play out. In 2018, the Kerala floods caused multiple shallow landslides, primarily triggered by the heavy monsoon rains that swept through the region. These landslides can be quite destructive, especially when the rainfall is intense and prolonged. Moving on to Maharashtra, specifically Lonavala and Matharan, these are popular tourist destinations and also have many residential areas. There, slope failures have been observed along the slopes near these areas, often as a result of heavy rains weakening the stability of the terrain. These examples highlight how intense weather events, like heavy monsoon rainfall, can trigger slope failures in different settings, whether in rural, urban, or recreational zones. It underscores the importance of understanding and managing slope stability, especially in vulnerable regions, to prevent such disasters and protect lives and property. Let's take a closer look at the factors influencing landslides in these two regions. Starting with the Himalayas, this area is characterized by young fold mountains composed of fragile rocks, which are more prone to erosion and instability. The slopes here are very steep, with narrow valleys, making the terrain inherently vulnerable. The region experiences high monsoon rainfall, often leading to seasonal floods, which further weaken the soil and rocks. Seismic activity is also high, as the Himalayas are earthquake-prone zones, increasing the risk of landslides during seismic events. The soils tend to be weak and highly erodible, and human activities like deforestation, road cutting, and urbanization exacerbate the problem. As a result, landslides here are typically deep-seated, involving debris flows and mudslides. Now, shifting to the Western Ghats, this region features ancient, stable rocks with lateritic soils. The slopes are generally moderate to steep, but not as extreme as in the Himalayas. The monsoon rainfall is extremely high, with intense rain events that can trigger landslides, though the overall seismic activity remains low. The soils are mostly lateritic, shallow, and prone to erosion, but the stability differs from the Himalayan terrain. Human influences such as plantations, hill cutting, mining, and deforestation are common, which disturb the natural stability of slopes. Landslides here tend to be more shallow, involving soil slips, mud flows, and soil slips rather than deep-seated movements. In summary, the Himalayan region's young geology, steep slopes, and seismic activity create a different landslide profile compared to the Western Ghats, where older rocks and human activities play a significant role. Recognizing these differences helps us develop region-specific mitigation strategies and better understand the overall landscape dynamics. Now, let's look at some key insights about landslides in these two regions. In the Himalayas, landslides tend to be mainly deep-seated, meaning they occur deeper within the mountain slopes. These are primarily triggered by steep slopes, earthquakes, and heavy rainfall, which destabilize the terrain at a fundamental level. Recognizing these factors helps us understand the complexity of managing landslide risks there. In contrast, the Western Ghats experience mostly shallow slips. These are often caused by intense rainfall, which weakens the soil near the surface, and human activities like slope modifications for agriculture or development. These shallow slips are more immediate but still pose serious hazards. The key to effective mitigation, then, is tailoring strategies to each region. For the Himalayas, we need to focus on stabilizing slopes. This includes reforestation efforts to hold the soil together and building seismic-resilient infrastructure to withstand earthquakes. Meanwhile, in the Western Ghats, controlling plantation cutting to prevent excessive soil exposure, ensuring proper drainage systems to handle heavy rains, and regulating road construction to avoid unnecessary slope destabilization are crucial steps. By understanding these regional differences, we can develop targeted solutions that effectively reduce landslide risks and protect communities. So, to wrap up, both regions we've discussed are indeed vulnerable to landslides. However, it's important to remember that the causes behind these landslides can vary quite a bit, depending on factors like geology, topography, climate, and even human activity. These differences mean that a one-size-fits-all approach won't be effective, and understanding these regional variations is absolutely key for managing landslide risks effectively and mitigating disasters. What this really highlights is the importance of tailored strategies. Knowing what causes landslides in each area helps us develop better prevention and response plans. And ultimately, sustainable development practices, such as reforestation and careful planning, are crucial tools in our arsenal. They help reduce the risks, protect human lives, and safeguard property. So, by integrating this understanding into our planning, we can make more informed decisions and work towards safer, more resilient communities. This is the core message that ties everything together in our overall effort to manage landslide hazards more effectively. Thanks for watching. I really appreciate you taking the time to go through this presentation with me. If you found the content helpful or interesting, please remember to like and subscribe to UX Magazine. Your support helps us create more valuable content like this. Thanks again, and I hope to see you next time.